Start with the great name of Allah, who's the most Rahman and Rahim, who's the most Qadir and Kareem. This is Babar Ali, student of third year Department of Computer Science, and today we will learn the numerical analysis. The agenda and these are the contents which we will discuss about. What is numerical analysis? Bisection method, working rules of bisection method, rounding to significant figures, rounding off, and in last, the floating point and error. So first of all, the history of numerical analysis. The field of numerical analysis predates the invention of modern computers by many centuries. Linear interaction was already in use more than 2000 years ago. Numerical analysis. Numerical analysis is the branch of mathematics that deals with the development and use of numerical methods for solving problems. The overall goal of the field of numerical analysis is the design and analysis of techniques to give approximate but accurate solutions to hard problems. It is the study of algorithms that use numerical approximation for the problem of mathematical analysis. Use of numerical analysis, usually used in computer science for root algorithm. It is used to determine profit and loss in the company, used for multidimensional root finding, solving practical technical problems using significant and mathematical tools, network simulation, train and traffic signal, weather prediction. And now we will discuss the bisection method. The bisection method, the most basic problem in numerical analysis is the root finding problem. The bisection method is a root finding method that applies to any continuous functions for which one knows two values with opposite signs. Working rules steps. Find 2 points, say A and B, such that A greater than B and F A B. Find the midpoint of A and B. Find the X. Now significant figures. Significant figures, number of significant figures indicates precision. Significant digits of a number are those that can be used with confidence. The number of certain digits plus one estimated digit. The term significant figures refers to the number of important single digits, 0 through 9 inclusive, in the coefficient of an expression in scientific notation. Significant figures in a number use the following. Non-zero digits are always significant. If you have 0 at start or end, it does not count as significant. Zeros are only significant if the number contains a decimal point 0 between two digits, like 0.1 and 1304 does count. Examples: 4.2362. Here is all non-zero numbers, so 5 significant. 2.0 zeros after a decimal point count, so 2 significant. 9900, only 2 significant in this case because there is no decimal point. 0.44205, there is a captive 0. which means it counts so 5 significant. 0.05 only the 5 count so 1 significant. 3.9400E9 tricky one, but scientific notation helps make the zeros at the end noticeable. There are 5 significant. And now rounding off. Rounding off, rounding error and the difference between a rounded off numerical value and the actual value, a rounded quantity. In simple rounding, In simple, rounding means making a number simpler but keeping its value close to what it was. The result is less accurate but easier to use. Example 73 rounded to the nearest 10 is 70 because 73 is closer to 70 than to 80. Rounding off. Here's the general rule for rounding off. If the number you are rounding is followed by 5, 6, 7, 8, or 9, round the number up. Example 38 rounded to the nearest 10 is 40. If the number you are rounding is followed by 0, 1, 2, 3, or 4, round the number down. Example 33 rounded to the nearest 10 is 30. What are you rounding to? When rounding a number, you first need to ask what are you rounding it to. Numbers can be rounded to the nearest 10, the nearest 100, and the nearest 1000, and so on. Consider the number 4827. 4827 rounded to the nearest 10 is 4830. 4827 rounded to the nearest 100 is 4800. And 4827 rounded to the nearest 1000 is 5000. And now the floating point. The floating point in programming, a floating point or float is a variable type that is used to store floating point number values. A floating point number is one where the position of the decimal point can float rather than being in a fixed position within a number. Examples of floating point numbers are 1.23, 87.425 and 9039454.2. Different programming languages or systems may have different size limits or ways of defining floating point numbers. Refer to the programming language documentation for details. Error. So the errors, since numerical solutions are an approximation and since the computer program that executes the numerical method might have errors, the numerical solution needs to be examined closely. There are two major sources of error in computation, truncation errors and round-off errors. So here the presentation ends. Thanks.